Integrated Math 3, this is assignment 4.05. This is the answers video for that. And this assignment is due on Tuesday, November the 17th. Alright, so the first question says, solve the exponential equation. Use a calculator to obtain a decimal approximation. Correct to 2 decimal places. That, is fine. 2 decimal places is good. Alright, so what you do whenever you have a variable up inside of an exponent, that makes it an exponential equation. And what you have to do to get that variable out is to do the inverse of an exponential, which is a log. It could either be a natural log or a common log. Usually we're going to use common log, but I'll show you both on this case. So you're simply going to take this equation, and over here we'll use the natural log, the common log rather, of 19x, 19 to the x power, and on the other side we're going to take the common log of 143. So anything you do to one side you do to the other. We're going to take the log of both sides. Okay, so on the left side, rule number 10 says that if you have a variable, or it could be an entire polynomial, it could be anything up in the exponent in front of a log, or behind a log rather, you can pull it out in front of the log like this. Alright, so we're going to do that. Okay, there's nothing we can do to simplify this with a common log. If this was a 2 and this was an 8, they would both be exponents, powers of 2, but there's nothing we can do there. So you simply have to take the numeric value of this, and then just solve the equation algebraically. So the log of 19 is going to be 1.28. And the log of 143 is going to equal 2.16. And so we're simply going to divide both sides by 1.28 to solve for x. These cancel. And you get 1.68 as your answer for x. And you check your work by raising 19 to the 1.68 power and see if you get 143. It's going to be off by a little because we rounded all these numbers here, but it'll be fair, close enough that you can say, yeah, that was it. Alright, so we've got 19 raised to the power, that's the little caret sign, the hat, and we're doing 1.68, and it's going to give us 140.7. That may seem like it's off by quite a bit, but we did quite a bit of rounding here. These numbers were actually, 7 digits out. So that's good enough. We'll take that as a check. 140.7 is close enough to 143 that we got that. Okay, let's do it with the natural log. Same thing. So instead, this time I'm going to take the natural log of 19x. 19 raised to the x. Same thing, natural log of 143. All this is, natural log is log to the base e, which is 2.71, Euler's number. Alright, so we do the same thing here. Okay, now you're going to get different numbers here, but you should come up with the same final answer. So natural log is this ln button right here. It's a little blurry. It's that ln button right there, and I'm going to put 19 in, and it's 2.94. Okay, and ln 143, close the parenthesis right there, and you get 4.96. Okay, divide both sides by 2.94 to solve for x. And what you get is 1.68. Same thing. 1.69 actually in this case, a little closer. It doesn't matter, they're the same. We're just rounding, and that's causing some rounding error. Okay, so in other words, you could use either natural log or common log for this problem. Okay, you do not have to do it both ways. This is perfectly fine. Okay, let's keep going. 2. Okay, next one. You have Euler's number, e raised to 4x minus 5, then minus just the whole number 7, and that equals this. So the first thing you do is just combine this and this by adding to both sides. And that's what that leaves you with. Now since we have e, we're going to use the natural log. So we're going to go ahead and do that. Natural log of e. Okay, so natural log of e, those are inverses of each other. So what that's going to do is you don't have to pull the 4x plus 5 out front, they go away. They both inverse, they reverse each other, like plus and minus reverse, like multiplication, division, reverse. So you simply have on this side, and now you run this on the calculator, the natural log. Natural log 11,250, close the parenthesis, and we get 9.328. Okay, and now at this point, it's just simply an algebra problem. We're going to add 5 to both sides. Okay, and that gives us 3.582. Okay, you want to check it out, come up and plug it in here. I'm going to do that. I'm not going to do it on screen. I'll do it on screen, yeah. How do you do that? Okay, you got to get e to the x, so it's a second function here, so it's second e to the x. Now I'm going to go ahead and put this in 4 times x, but x we know is 3.582, or we believe that's what it is, and then minus 5 right here. And I'm going to close that parenthesis, and I get 1,248, and I subtract 7 from that, and I get 1,241, which is pretty close to 11,043. Again, let me get this in focus for you. Again, this is rounded. I got 1,241.6. It's all the rounding error here, okay, when we round things down. Okay, that for example, that log of 11,250 is not precise. All right, so as long as you get within 1 or 2, you probably have it right. You almost certainly have it right. Okay, let's keep going. All right, same thing. Okay, and we did these in class. This is just your chance to catch up if you weren't in class or if you missed something or didn't get something written down. Okay, again, what we're going to do is we can go ahead and just raise these to make logs out of these. Okay, now what we can do now is use rule number 12 again. Again, it's not officially a rule number 12, it's rule number 12 on my sheet, on this sheet here. Okay, so it's log a raised to the x. You can bring the x out in front. Now you may say, why can't we just cancel the log like we did with the last problem? The log and the natural log and the e canceled out. That's because natural log and e are inverses of each other. But common log is base 10. It's not an inverse of 5. It's not an inverse of 3. So you can't do that. You can't just cross out the log and the 5 and have 2x plus 3. It doesn't work that way. If this had been a 10, then you could have done that. If this had been a 10, then you could have done that. But it's because it's a base 10 times 10, base 10 of 10 raised to some power. So that would be an inverse. This is not an inverse. It's base 10, and then the argument is 5. So what we can do, though, is bring these out front, the 2x plus 3. Okay, now you have a couple of logs that you can compute on the calculator. I won't do that in front of you. I won't do that on the camera. I'll just do it here. The log of 5 equals 0.699. I'm going to call it 0.699. And log of 3, this one right here, log 3, close the parenthesis, and you get 0.477. Okay, now what? Well, now it's just algebra. Rather than distribute this through to this and this through to this. That leaves a whole lot of messy decimal numbers. Let's just deal with one decimal number. So what we're going to do is divide both sides first. You could do that, but we're going to do it this way. Okay, so these two cancel out. And these two give you this. These two give you that right there. Okay, now you're going to have to distribute this through, but it's a fairly easy distribution. You can do it in your head. This side doesn't change yet. That times x is going to be, and that times -1 is going to be this. Okay. Now you collect the x's on one side and you collect the x's on one side and you collect the non-x's on the other side. So what we're going to do is we want the x to be positive, so we want to subtract this rather than this, so we're going to do this. Goes away. What you get here is 1.317 plus 3 equals this over here. Okay, and that should be x. Yes, I'm sorry. That should be x right there. X, and now you subtract 3 from both sides. I'm going to bring it up here so I have more space. Okay, and this is going to be -3.683. Okay, just this minus this gives you that, and that goes away, of course, and then you had that already, 1.37, so you divide. Okay, so now we have this up here, and that's going to be -3.683 divided by 1.317, and that gives us a -2.8. for our answer. Okay, and again, you can take this, plug it into the original equation up there, and if you do, you will find out that this side will equal that side right there. Okay? All right, here we go. Let's keep going here. All right. So we're going to go ahead and solve this for x. And you have a base 5. So what do you do with a base 5? How do you get an inverse of a base 5? Well, if you wanted to do an inverse, if this was a base 10 and you wanted to do an inverse, you would write it like this. 10 raised to the log. And you don't write the base 10 normally, but if you don't write any base there, it's a base 10 of x is going to equal x. Okay? Here you have a base 5, so how do you deal with that? It's not a base 10. It's not a log base 10. You simply use the number 5. So it's going to be 5 raised to log 5, and now you have an inverse. Okay? That's your base, and that's your base, so they're the same. And then that's going to be the same over here. It's going to be 5 raised to what's on this side, which is 2. Okay, so now these do wipe each other out. They go away. And so what you have left simply is that x minus 7 equals 25. So add 7 to both sides. And x equals 32. That's your answer. All right, and you could go back and check that by plugging that in there. That would be log 5. That would be 32 minus 7 would be 25 for that. And what a log base 5 means is what exponent do you have to raise 5 by to get that number 25 that we would have there? The answer is 2, and that's what you have there. So that checks out. All right, let's keep going. All right, So solve this equation, and it's all log base 6. So we're going to first of all use rule number 10, which says that if you have a log of some base of the argument A plus log of the same base of argument B, you can multiply the two arguments together like that and inside of a single log. So we're going to do that. So we're going to do this. Okay, so we just multiplied this and this together inside of a single log. That's what that rule says you can do. All right, now what we're going to do is we need to get an inverse. We need to get all this unwrapped out of here. So what I'm going to do is raise this. Since it's a base 6, I'm going to do what I did on the last problem with a 5. I'm going to make it 6. And on the other side, it's 6 squared. So this all comes out, and this you can just simplify to 36. Okay, it looks like we have a quadratic shaping up here. So let's go ahead and turn this into a quadratic. X times x is x squared, x times 5 is 5x. And now what I can do is subtract 36 from both sides. And now you do have a quadratic that you can factor, because it's set equal to 0. So you can factor it, you can set the zeros. And which in that case is the values of x that you're looking for. Okay, so here's our quadratic right here. So it has to multiply to negative 36 and add the positive side. So let's just come up here and do some factoring. Okay, since it multiplies to a negative number, then one of the numbers has to be positive and one has to be negative. Since it adds to a positive number, the bigger of the two has to be the positive number. So I'm going to start with a small negative, negative 1 times positive 36. The bigger one is the positive number. And that's going to, when you add those two together, you get negative 35. That's not what we're looking for. We're looking for 5. Next is 2. 2 and 18, negative 2 and 18. You add those together, you get 16. That's not what we're looking for. Next is 3. There's a whole lot of numbers that divide into 36. Negative 3 times 12. And negative 3 plus 12 would give you 9. That's still not what we're looking for. Next is 4, negative 4 and 9. And negative 4 plus 9 will give you positive 5. That's the one we're looking for. So these are the numbers that we want. So it's going to be x minus 4 times x plus 9. These two numbers right there. Okay, and the zeros, you set them equal to 0. That's what we have down there. So what makes this one go to 0? Positive 4. Positive 4 minus 4 would be 0. So that would be 4. And what makes this one go to 0? Negative 9. So those are your two answers. And that would be x equals positive 4 and negative 9. Okay, so that's how you do that problem. Okay, I am going to leave 6, 7, and 8 for you to do. Let me give you, let's see. Let me give you a little head start on them, okay? So I'll do that. So here you have a log of something plus a log of something minus a log of something. So I'm just going to give you a head start here, okay? What this is going to be is you're going to use both rules number 10 and 11 to do these. That's the plus log, and the log minus log. Log plus log is a multiplication, log minus log is a division. So let me just get you started. This one is going to be log of base 2. So that means if you want to raise it to a power, you would raise 2 to the power. And you put all of these can fit in this one log here. So watch what I do. It's x minus 3 plus, and then the x, so that's going to be times. Over, and then this is a subtraction, so it's x minus 2. Okay, and that equals 2. And I'm off screen, sorry. Okay, so let me say it again since you may not have seen it. It's x minus, this is x minus 3 plus the x here, log 2 of x. So you're going to multiply those two because it's a plus sign. And then it's a subtraction of this x plus 2. So that's going to go on the bottom. These two are going to be divided by that, all right? Okay, so what you need to do is raise this to put some base there to raise both of these to some power. What number are you going to use? Figure that one out, okay? Come to tutoring if you want to see how to do it. This one gave me some problems with students, so what I'm going to do is give you a hint. You can't right away convert that into a normal number. It is log of 3. The log of 3 is 0.477. But you don't want to do it that way. You want to do it this way. And it is a base 10 log since there's nothing there. So it's going to be like that. And then this one's going to be okay, so there you go. You got two base 10 logs. You need to get all this stuff outside of the log, so we showed you how to do that. And the last one is the same thing, except it's a natural log. So if you're going to raise this to a power, an ln to a power, it's e, not 10. Okay? It's e, whoops, e to the, rather, ln. Okay, like that. All right? So those are for you to do. All right, that's it. That's the homework. It's due Tuesday. You got some time for that. Come to me in tutoring. You got plenty of time on Monday and Tuesday for tutoring if you have questions on any of those. Okay, we'll see you in class on Monday or Tuesday.